In this lesson, we shall focus on applications of differential calculus, and we shall focus on the question on the board. Right, question 5. A rectangular container is a square base and contains 1 liter of milk. The container has a folding lid that covers 3 times the area of the base. The length of the side of the square base is x centimeters. Right, and that is what we're able to see over there. Right, x centimeters is clear here. And the height of the container is h centimeters. 1 liter is 1,000 cubic centimeters. See the diagram below. Show that the area A of the cardboard used to make the container can be expressed as this. Right, can be expressed as this. Right, so yeah, please try this question. Let me know when you're done. Please let us know when you're done. Show that the area A of the cardboard used to make the container can be expressed as this. Quickly in your scribbler, tell us when you're done. 5.1. 5.1. I have a strong feeling there's a question like this that's coming tomorrow. Rectangles. Rectangles. Right, please let us know when you're done. How far, Lesedi? How far, Neo? Shall be here until 8. There are too many questions shall do. Right, we continue. Anybody home? Who is done? Who is done? Isadi, how far? Neo, how far? Okay, the container is a folding lid that covers 3 times. It has a folding lid. Okay, I can imagine it's a little bit tricky. Don't think too hard. Don't think too hard. Isadi, how far? Okay, see, the area of the cardboard is what we call the total surface area. It is what we call the total surface area. And the total surface area, the container has a folding lid that covers 3 times the area of the base. 1, 2, 3, 4. in other words, you have 4 times the area of the base. 4 times area of base. Plus, the box is rectangular, so it has 4 faces. 4 times the area of the vertical side. Right, the area of the vertical side. What is the area of the base? The base is a square. Length by breadth, side by side. So the area of a rectangle is length by breadth. That's what you're going to use. So it means, but this is x by x is x squared. But the container has a folding lid that covers 3 times the folding lid at the top of the carton. It covers 3 times the area of the base, like 1, 2, 3. Okay, so, but it's 1, 2, 3, 4. So it's going to be actually 4 of the x squareds. Right. Now, then, the area of the vertical side. The vertical side is length by breadth. So we can call it XH. We can call it XH. But now you have the volume. What is the volume of anything? What is the volume of anything? You see, the volume of anything is simply area of base. The volume of anything is area of base by height. And this means to find the volume, what is the area of the base? The area of the base is side by side, like it's a rectangle, so it's x by x, which is x squared, multiplied by the perpendicular height of the carton. But we know very well that this rectangular container has a square base and contains 1 liter of milk. There is 1 liter of milk. Right, so if there is 1 liter of milk, what do you do with the 1 liter of milk? We have exactly 1 liter of milk in the carton. So this is the carrying capacity of the carton. This carton here is contains some milk inside. Okay, so but it's 1 liter. But in other words, it is exactly 1 liter. That is the volume. So if the volume is 1 liter, it means that we have x squared height multiplied by 1,000. 1,000 cubic centimeters, meaning the height is equal to what? The height is 1,000 divided by x squared. This is it. This is it. So it means to deal with this topic on applications of calculus, we must be able to find the area. The height is 1,000 divided by x squared. That is the height. 4x squared plus x divides, and 4 times 1,000 is 4,000. X divides into x squared, giving us only x. And this is the answer. Where's the question on this particular past exam question, past metric question? Who doesn't understand anything here? I have a strong feeling there's a question like this tomorrow. I personally have a strong feeling there's a question like this tomorrow. But who does not understand what we have done? Yeah, good. What does it mean to say the lead covers 3 times the area of the base? It means the lead has 3 ears. It has 3 ears. 1, 2, 3. And these 3 ears, each one of them is the same size as the base. So it can fit. This ear number 1 can fit like the ears you have on the head. And then ear number 2 is the same size as the base. Ear number 3 is the same size of the base as well. So you see, when they say the container is a folding lid that covers 3 times the area of the base, to find the area A of cardboard, the area of the cardboard, we must find the area of the leaves, because these ears here also, they are part of the cardboard that must be cut to form the carton there. And therefore, if we're told that the folding lid covers 3 times the area of the base, 3 times the area of the base, it means that yes, 1 ear, 2nd ear, 3rd ear, like 3 ears. Any question? Who is confused? Who wants to ask anything? All right. Yeah. All right, let's explain again. The container has a folding lid. This lid is at the top. You know, after drinking the milk, you can close the carton again. You can close this one, close this one, close that one. But there are 3 sections of the leaf, so of the lid. So the container has a folding lid that covers 3 times the area of the base. So if this folding lid covers 3 times the area of the base, it means that this folding lid is big, but it's 3 times the base. It's 3 times the base because it's 1 lid, 2 lid number 2, lid number 3. So these 3 leads, but they work together. But each one of them covers 3 times the area of the base. So it's 3 of these, 3 of these, 3 of these, 3 of that. Where's the question? Where's the question? So that is why we're then saying 1, 2, 3, 4. 1, 2, 3, 4. Right, so you have 4 of the area of base. 4 of the area of base. Yeah. Yes, please. Yes, my dear. Okay, let me check. Okay, let me check. Okay, let me check. All right, my dear. Right, let's see. Right. Okay, yeah. Where's the question here? Let's say it. Okay, because now it means that there are 1, 2, 3, 4 of the area of base. This is like the area, same size as the area of the base, but 1, 2, 3, 4. So we have 4 area of the base, and then there are 4 sides. 1, 2, 3, 4. But each one of them is the same. What has the same area? So that you just have to say length by breadth. Okay, length by breadth. Right. So we continue. We continue. Yeah, who's lost here? Okay, let's look at the next question. Determine the dimensions of the container in centimeters so that the quantity of cardboard used is as small as possible. So we know that the area is what? Is 4x squared. 4x squared plus 4,000 times x to the minus 2. Let us find the derivative of this, which means that we can determine dA dx. Right, so if we determine the derivative so that this is as small as possible, we need to find the minimum. As small as possible, you need to find the minimum. So you find the derivative. 4x squared has the derivative 8x. Very well done there. So that is x to the power minus 1 for that x. So it's x to the power minus 1 for that part there. I'm glad that you are very much wide awake. Right. So let us continue then. So that then we have minus 4,000 x to the minus 2. And therefore this derivative is equal to what? The derivative is equal to 0. Where's the question? Right. Where's the question? Where's the question? Right. Where's the question? Okay. So this must be equal to 0. Then we need to solve for x. So which means that we have 8x minus 4,000 divided by what? Divided by exactly x squared, and the result becomes 0. Multiply through by x squared. So that you get exactly 8x. But now we multiply it through by x squared. This is going to be a cube, and you subtract 4,000. Subtract 4,000. Right, and after subtracting 4,000, the result becomes exactly 0. Right, so which means that x cubed is exactly 4,000 divided by 8. What is 4,000 divided by 8? Let's check this out. What is 4,000 divided by 8? Okay, I'm checking on the calculator. Right, so you're going to have exactly 4,000. So we have exactly 4,000 divided by 8, which is 500. 4,000 divided by 8 is 500. So that x becomes the cube root of 500. Okay, you see, once you take the cube root of 500, what's the answer? Okay, I'm just using a calculator to check the cube root. Right, so you have the cube root. Right, the cube root of 5,000. Which is 17.099. We can call it 17.1. So you can do, actually, this is exactly 17.1 centimeters. Good. Good, let's say it is indeed 500. For that. So that now x is 17.1. Okay, so this is one of the dimensions. But you already know from the previous question that the height is 1,000 divided by x squared. Which is, the height is what? 1,000 divided by x squared. So 1,000 divided by x squared. The x is 17.1, and then you square it. And so that is going to give us the answer, because we need to determine the dimensions in centimeters. Right, so we continue. We continue. Right, so yeah, when I use the calculator, maybe you've already got the answer. Okay, yeah, I'm going to check the charts, please. Just a second. So you square this answer. You take its reciprocal. You multiply by 1,000, which is 3.42. Yeah, 3.42, that's the answer. That's the answer. Where's the question? Who doesn't understand anything? Let me check the chats. Okay, yeah, Lisette is asking, how is X 17.1? What did you get as the answer, Lisette? What are you getting now? What is the cube root of 500? Cube root of 500, what are you getting now? Okay, I want to check your calculators and to see who's maybe there's a calculator issue here. Now, what is the cube root of 500? Just testing. Please, can you do it? Okay. Let me check. Let me check. I'm glad that. So I'm gonna check this out. Just 1 minute. I want to check the cube root. Cube root of 500. Okay, it is 7.94. I'm glad that you're able to check get that one. 7.94. I'm wondering why it went to that. Maybe there was computational error. 7.94. You agree? Okay. So now you can come here and use that. So you can leave it as the root. Or then you can come here and determine this exactly. I'm glad that you're wide awake. That's 7.94. So it's 7.94 centimeters. So 7.94 centimeters, and then you square it. What's the answer here? What is the answer there? Okay, Yar. I'm just using a calculator to check that we are indeed getting correct answers here. So now you're going to square this one, take its reciprocal, multiply by 1,000. Yeah, it comes down to 15.87. 15.87 centimeters. Where's the question? Okay, anything you want to know, anything you want to ask, anything you want us to change. Maybe you're thinking we missed a minus. Please let us know. Or there's something. Okay, let me check the charts. Okay, yeah, anything, please let me know. Are you happy with this? What should we change? What should we not change? Please. What should we change and what should we not change? Please. What's the question? Who is not happy? Who is happy? Who is not satisfied? And who is satisfied? Right, that's a good question. Why did you solve for H? Well, because the question said determine the dimensions of the container in centimeters so that the quantity of the cardboard used is as small as possible. So to determine the dimensions of the container, we must, the dimensions, what are the dimensions? It is H for the height and X, because the base is the square. So we must just get X, which is exactly the dimensions of the base. They are both the same. The length and the breadth are equal, so we're dealing with the square. Where's the question? Where's the question? Where's the question? Anything? Okay, let me test you now because you're not asking me questions. Let me ask you. Then I'm going to ask you a question. Right, how did you get the equation for H? Okay, to get the equation for H, we use the volume. How did we get the equation for H? We know that volume is what? It's area of base by height. Please learn these things for tomorrow. If they bring something rectangular, because if they bring geometry in the applications of calculus, then you must know how to find the volume of anything. But the volume of anything, whether it is a cylindrical shape, it is area of base by height. So the base is a rectangle or a square. So that the area of the base is x squared and the height is h. So the area of the base is length by breadth. So it is x squared and the height is h. And then the volume of this is what? We're told here the rectangular container has a square base and contains 1 liter of milk. 1 liter of milk. So the volume is 1 liter. 1 liter. Okay, so now if the volume is 1 liter, but 1 liter is 1,000 cubic centimeters. 1 liter is 1,000 cubic centimeters. So that in the place of 1 liter, you put 1,000. In the place of 1 liter, you put 1,000. And then you divide by x squared so that the height is 1,000 over x squared. 1,000 over x squared. So that the height is 1,000 over x squared. The height is 1,000 over x squared. So that is how we found the height. Where's the question? Who is confused? Who is confused? Who is not sure of what we're doing here? Who is not sure of what we're doing here? Who is not sure of what we're doing here? Who is not sure of what we're doing here? Where's the question? Okay, you are not asking me questions. So now I'm going to ask you a question. Okay, an advertising company has asked you to design an advertising disc that consists of 4 semicircles and has the shape as shown in the figure. An advertising company has asked both Lesedi and Neo has asked you to design an advertising disc that consists of 4 semicircles and has the shape as shown in the figure below. Okay? So these are semicircles. Semicircles, the word semicircles suggests half circles. So these are half circles. The larger semicircles have radius r, and the smaller semicircles have radius small r. The value of r, the values of big R and small r may vary, but the sum of the radii, big R plus small r, is 200 millimeters. To minimize costs, the company has stated that the area of the shape must be a minimum. To minimize the costs, the company does not want to spend a lot of money on the on the discs. But they're saying, you know what, just to design something simple. Design something simple. They gave you that task, you are a grade 12 learner. Show that the area of the figure is given by A equals 2 pi r squared minus 400 pi r plus 4,000 pi. You have 3 minutes. You have 3 minutes. Tell us quickly. You have 3 minutes. Show that the area of the figure is given by that. You have 3 minutes. Any question? Quickly, please solve and tell me when you're done. 2.1. If you can't see the question, let us know. How far, Lisedi? Who is done? Lisedi, how far? Neo, how far? How far? Lisedi, what's the answer? Leo, what's the answer? Guys, I need the answer. All right, Lisedi is saying he's still a little bit stuck. He's thinking about what to do. Lisedi is saying he's a little bit stuck and he's thinking about what to do. Lisedi is saying he's a little bit stuck, so he's thinking about what to do. So now, how far? All right, now he's saying he's thinking about it. I'm giving you 2 more minutes. 2 more minutes. Two more minutes. Right. I'm waiting. I'm waiting. I'm waiting. I'm still waiting. Anybody home? Okay, this question is too easy because you are thinking too much, you see? What you need to do here is to take this diagram, draw the big circle like this, draw the small semicircle like that. Take this small semicircle and these things you alter their positions. And then you also have this one. So these things are the same. They're exactly the same. So now here you would then have a full circle with a big radius. Here you have a small circle with a small radius. So now to find the area, you need to then say the area is pi radius squared, is the area of the big circle, plus pi radius squared, the area of the small circle, okay? So now everything here is in terms of the big R, so you must just get rid of the small r. But we know, we've been told that R, big R plus small r is 200. So we can make small r the subject, getting 200 minus. Okay, let's see how to get the 4,000. So when you solve small r, we have 200 minus big R. So you're going to come here and then say this is pi radius squared plus pi. What is the radius? It's exactly 200 minus big R you square. Because here, if you move the big R to the other side, it is 200 minus the big R, which means the area is pi radius squared plus pi. Let us square this guy. Okay, if you square 200, you square the 2, you get 4, and then 4 zeros. 4 zeros. Plus r squared. Then you distribute, you open up the brackets, which means this is actually exactly pi r squared plus 40,000. Pi minus 400. Pi r, and then you put pi r squared. What is then the area? Pi r squared plus pi r squared is going to give us 2 pi r squared. Minus 400. Pi r plus okay, I need to check this if it's 4,000 or it's 40,000. Need to check it. Okay, we're going to check that one. Let me use a calculator to be 100% sure. Okay, we're going to square 200. It's 40,000. 40,000. Because there was just a typo there from the person who typed these. It's supposed to be 40,000, yeah? So, yeah, but this is the answer. Where's the question? Where's the question? Who does not understand what we have done? Who is lost somewhere? The shape was made too difficult, but you could just move. This is the power of geometry. You can move this thing and put it here. Move this one and put it here so that it forms a shape that is regular like this. And then now you can say, okay, this is a big circle of radius r, not just semicircles like that. Who is confused? Any question, Lesedi? Any question, Newo? Who is confused? Okay. Lesedi, where are you lost? Do you think we missed a 2 somewhere? Do we need to put a 2 or a 3 somewhere? Please let us know. Right. Next question. Okay, use differential calculus to determine the values of r, big R and small r if the area A is to be a minimum. Two pi plus 4,000. So dAdr would be 4 pi r to find the derivative minus 400 pi. This one is a constant, 0, but this must be 0 for minimum area. Yeah, right. So we must use 40,000 because they made a mistake here. But just that it's not, yeah. So here it must be 40,000 pi. Right, so you're going to use 40,000 pi, but the derivative is that for minimum. 400 pi divided by 4 pi, 100. So if big R is 100, big R plus small r is what? Is 200. Okay, yeah, so this is what we have. But we know that everything is in millimeters, of course. But big R is 100, which is 200. Then small r is 100. Small r is 100 millimeters. Small r is 100 millimeters. So they're saying use differential calculus to determine the values of big R if the area A is to be a minimum. So the values of the big R and the small r. So the big R is 100 millimeters and the small r is also 100 millimeters. Any question? Consider solution in question 2.2 and explain why the shape suggested by the company is not possible if you want to maintain a minimum area. Right, so you need to explain to them that why the shape is not possible if you want to maintain minimum area. Right. Explain to them why the shape is not possible if you want to maintain the minimum area. Okay, so let's look at that 2.3. I'm giving you 2 minutes to do 2.3. 2 minutes. Right, only 2 minutes, please. Yes. Okay. Right, I've seen Noah's answer. So what would you think is the answer, Lisedi? What would you think is the answer, Lisedi? Why, Lisedi? Okay, the reason is that the company, yeah, Okay, I can see your answer. They say, Neo. They said, why? Why would the shape not be possible? You need to explain to the company that the shape is not possible. Why? Why? If you want to maintain a minimum area, why? They said, I've seen Neo's answer, but I want to know what Lesedi is thinking. I'm giving you a chance, guys, to shine. Why would you tell the company the shape is not possible? Why? Why would you tell the company the shape is not possible? Why would you tell the company the shape is not possible? Why? Lesedi, why? Okay, I can see what Neo is saying, but I can't just say the answer of Neo yet. Because I want to know what Lesedi is thinking. What do you think, Lesedi? But they're saying consider your solution in question 2.2 and explain why the shape suggested by the company is not possible if you want to maintain a minimum area. If this is to be a minimum area very small, you must tell the company that it's not possible. It's not possible. Why would you say it's not possible? What explanation are you going to give to the company? That you want me to make the area minimum, but this is not going to work. Why? Why is it not going to work? Why? You must explain to the company. Why? Lesedi. Why? Lesedi. Why? You must tell the company that what they want is not possible for you to design because you're supposed to design. But what explanation are you going to give to the company that the design you want is not going to work? What explanation are you going to give to them? Yo, that's the answer. So the answer is that both of these radii are 100. Both of these radii are what? Are 100. So if both of these radii are 100, it means the shape is not possible because then you need one radius to be small and one radius to be large. But from the answer we got, both of these radii are 100, meaning that we're not going to have a smaller circle, a smaller semicircle, and then a bigger semicircle, because these radii are equal to each other, meaning therefore it is not possible because we have equal. It's not possible because of equal radii. Not possible because of equal radii of 100 millimeters. So it means that you're not going to have a smaller shape with a smaller radius and then a bigger radius, yeah? Okay, yeah, because you see, the company wants circles of a smaller radius and a bigger radius, smaller radius and a bigger radius. But what did you get for the radii here? Both radii are 100. Meaning, if they want a minimum design, a minimum area, then it's not possible because how can you have a smaller circle of radius the same size as a bigger circle? Because this is saying the radius of the of the bigger semicircle is 100, but even of the smaller second is 100. How? Then which one is smaller? Between 100 and 100, which one is smaller? 100 and 100 are equal to each other. So it's not possible because of equal radii of 100 for both bigger and smaller semicircles. Right. Not possible because of equal radii of 100 for bigger and smaller semicircles. Because they want a smaller semicircle, but it must have a smaller radius. But the radii are equal. They are both 100, 100, meaning that this is just going to be in the equal. You're not going to have a smaller semicircle or anything like that. So this design is going to shift because these circles are of the same size. The radius is the same for each one of them. For the smaller radius, the radius is 100. Bigger radius is 100. So there is no smaller radius or bigger radius here. Any question? Any question? Any question? Any question? Okay, let me give you another question because you're not asking yet. So I'm going to ask you this one. A rectangle has two vertices on the x-axis and two on the curve with equation y equals 4 minus x squared as shown in the sketch below. Express m in terms of x. Express m in terms of x. You have 2 minutes. You have 2 minutes. Express m in terms of x. 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 Right. Well done. There it is, Neo. Neo is right. We know that our m is equal to 4 minus x squared. Our m is 4 minus x squared. Our m is 4 minus x squared. Show that the area of the rectangle is given by this. Well, yeah. All right. Yeah, because this we have a rectangle A rectangle has two vertices on the x-axis, has two vertices on the x-axis and two on the curve y equals 4 minus x squared as shown in the sketch. So this one is a rectangle, meaning that the opposite sides are equal to each other. And therefore, in the end, you have x that comes there, and then this one is minus x. So the question is, how high do you go? This is the y value. And if this is a rectangle, the y value, this is x and that is y, meaning the y value is simply y is equal to 4 minus x squared. So that here you have minus x and this is 4 minus x squared, like so. Where's the question? Okay, yeah. Let me see what. Right. Continue. Right. So now it's a rectangle, so which means that y is equal to this. If this is a rectangle, then the y is the same. How high do you go? Because if you draw a graph like this, and then you then say this point is 1, 2, and this is a rectangle that is balanced, so that this one is minus 1. What is the y value? Because this is like parallel to the x-axis. So y is the same. Y is 2, because it is y, that is 2. X changes from 1 to minus 1. Yeah. Yes. That's correct. Yes. For 8.2, show that the area is this. Yes, good. Now, yeah, that's the thing. I received the answer from Lesedi for 8.2. Let me see what Neo is saying about 8.2. Let me see what Neo is saying about 8.2.
Ngithola ukuthi ifoni ilungile ne ngizokushutela yona ilungile yonke into i-right into engekho right asikhona ukuyivula ngoba uratile athi ukhohlwa i-password bekayisebenzisi so besicela ukuthi usinikeze i-email address yakho ne-password ngoba bowuyisebenzisa. So please ngiyacela ngoba njengoba iso angeke ngikhona ukuyisebenzisa ezofuna ukuthi bayiflash imali so this basingathula i-password yakho ne-email.
Right, so you continue. Right, determine the largest area. Yes, okay, we're gonna do 8.3. But yeah, Neo, how far are you with 8.2? I want to know. The area of the rectangle is given by this. All right, as indicated, that now here we have the y. This is x and y. This is parallel to this. So y is the same because it's what y is. So y is what here? So y is 4 minus x squared. Y is 4 minus x squared because y is the same. It's parallel. Whatever y is the same thing. But this is a rectangle, so it's the same height. Y is 4 minus x squared. Right. So now determine the area of the largest rectangle, which can be, okay, yeah, sorry. Show that the area of the rectangle is given by this. Area of the rectangle is length by what? Length by breadth. So what is the length? What is the length? Can you find this one, please? What is the length? What is the length of this rectangle? Who can give me the length? What is the length? What is the distance? That is the longest. What is the length of the longest side? Right. So what is the longest side? Yeah, I need the length of this shape. Who can give me the length of this shape? What is the length of this shape? So what is the length of this shape, guys? What is the length? Please. Anyone who can give, I want the length. What is the length? What is the length? The distance from here to here is the length. What is it? What is the distance, which is the length? What is it? What is the length? I want the length. I've seen 4x squared plus 10x, but that is not the length I want. Neo gave me 4x squared plus 10x, but it's not what I want. What is the length, guys? What is the length? Yeah, I've seen 4x squared plus 10x, but it's not. What is the length, Fox? The length of the rectangle. It is the x value, but what is that x value? I'm just teasing you. I know it's obvious, but I want to see who can. What is the length? It's not x. They said it thinks it is x, but it is not x. Neo said it is not x, it is not 4x squared plus 10x. What is the length? What is the distance from here to there? That is what I want. What is it? The distance from here to there. What is it? That's what I want. Okay, we're here until 8. It is 2x. It is exactly 2x. It is exactly 2x. I think I received that from Lisedi. So it's exactly 2x. So obviously, because we know already that the distance here from here to there is x. Here it is minus x. So what is the overall distance? X plus x is what? Is 2x. So the length is 2x. What is the breadth? The breadth, it is 4 minus x squared, which means the area is 8x minus 2x cubed. That's fine. You can use a distance formula, which can be longer, because we're just looking at the fact that now you already know this one is x and this one is minus x. So you have x plus x, which is 2x. That is the length. And then the breadth is 4 minus x squared. We have 2x times 4 minus x squared, which is 8x minus 2x cubed. So we continue. We continue. Okay, the next question is, so the length is 2x because it's x plus x and then 2x on the x-axis, yeah? And then the breadth is how high do you go is the y, and the y is this one. Length by breadth. The breadth is 4 minus x squared. You multiply, and now we got the answer 8x. 2x times 4, which is 8x, and 2x times minus x squared is minus 2x cubed. Determine the area of the largest rectangle which can be drawn in this manner. 8.3, quickly. I'm giving you 1 minute. It's too easy. Okay. Right. Right. Let's say he thinks it's tricky. Okay, because the area is 8x minus 2x cubed. Then what is the derivative? Because we want to find the largest, so we're looking for the maximum. So it's 8 minus 6x squared equals 0 for max. Okay, 6.15. Neo suggested. Okay, let's check it, Neo. So which means that 8 is 6x squared. You divide by 6, which means that you have 8 out of 6, which is x squared. Then x becomes the square root of 8 out of 6. Okay, only take positive because it's length. And so what did you get that one to be? Let's use a calculator. Let's use a calculator. The square root. 8 divided by 6. Which is exactly 2 to the square root of 3 over 3. Which is 1.155. 1.155. Okay, you can write it like that, but it's 1.155 there. Okay, that is the dimension. So now you need to find the area. You calculate the area of the largest possible rectangle. So the area is 8x minus 2x cubed. Which is the square root of 8 over 6. Okay, so you can just get an accurate answer like that. Which is the square root. Eight divided by 6. Okay. Minus 2. The square root of 8 divided by 6. Cubed. Yeah, Noah is right. It's 6.16. 6.16. 6.16. You're right, 6.16. Yeah. 6.16 square units. What's the question here? Who doesn't understand something? Okay, yeah, but your answer is correct now. It's considered correct as well. It's rounding off errors and things. So 6.16, 6.155 are close to each other. Pretty correct. Where's the question? Who is lost and who is confused? The municipality has decided to build a play park in one of the suburbs. It is to be rectangular with an area of 1,800 square meters. Palisade fencing needs to be erected on 3 sides. Okay, there's something called palisade fencing, but 1, 2, 3 sides. Since the 4th side already has a brick wall, there's a wall there. Let the length of and breadth of the play park be x and y respectively. So the length is x and the breadth is y. Determine expression for the total length L required. Total length of fencing L required in terms of x and y. Who can find that one in terms of x and y? You have 2 minutes. 2008 from the Western Cape Education Department. Western Cape Education Department, September 2008 trial exam. Okay, but we're doing 20.1. Determine expression for the total length of fencing required in terms of X and Y. Yeah, what is the total length of fencing? Okay, now what thinks that it is 2x plus 2y? Yup. Sadie, what is the total length of fencing? Right. What is the total length of fencing? Yeah, because this is y, and x, so it's going to be 2y plus x. Because the other x is a brick wall. There's a wall, so the fence is only on the three sides. So the total length of the fencing is going to be y plus y, which is 2y plus x. Y plus y, which is 2y plus x. Y plus y, which is 2y plus x. So this one is the third one. It's out. It's out. Determine an expression for the total length of fencing A required in terms of x and y. So total length of fencing is y plus y, which is 2y plus x. Show that the total length of fencing required can also be written as this. 20.2. You have 2 minutes. 20.2. You have 2 minutes. 20.2. You have 2 minutes. Twenty point two. You have 2 minutes. Twenty point two. You have 2 minutes. How far? Neo and Lesedi show that the total length of fencing required can also be written like that. How far? How far? How far? Neo and Lesedi, how far? Neo and Lesedi, how far? Show that the total length of fencing required can also be written like that. Why? Why is that L like that? Show. How? How is L equal to x plus 3,600 over x? How? How? Neo, how? How? Right, how? How? How far, Lisedi? Be faster, guys. We don't have the whole night. We're here until 8. We're here until 8. Why are you not finishing? Finish up. Show that the length of fencing is x plus 3,600 over x. Please finish. We are not here for the whole night. I want to see the answer. Right. So any question? Guys, faster, faster. Let's say the neo. 20.2, question 20.2. Show that the total length of fencing required can be written like that. What is the answer? So this one is the answer for 20.1. But you already know that the area. Yes. You made white a subject. That's okay now. So L is already these. But what is the area? The area is length by breadth. Yes. Good. Yeah, that is it. Good. So the area is 1,800. And then the area is a rectangle this. So the length is X. And then the breadth is Y. Okay. So this is the Y. So you put the Y here, which means the L is 2Y plus X. X plus 2. What is Y? What is Y? Please tell me. That is already the answer. We've done it. Where's the question? Who's confused? The answer is the blue one. Who is confused? Yeah. Okay, you got 1,800. But if it's 2y, so it's gonna be 2y. Y is 1,800 over x. We agree 1,800 over what? Over x. If you have 1,800 over x in the place of y, you put 1,800 over x. 2 times 1,800 is what? It's 3,600. It's 3,600. Where's the question? Where's the question? Where's the question? Where's the question? Determine the least amount of fencing that will be needed to complete the job. Do 20.3 quickly. 20.3 quickly. Right. 20.3, the length is already given by x plus 3,600 divided by x. X to the power minus. Let's find the derivative dl dx. And it must be 0. Which means x is what? 60. So if x is 60, then L, which is x plus, what is x? 60 plus 60. 60 plus 60, this will give us 120. So this will be the least amount of fencing. Okay, yeah, I need to confirm the calculator work here. For example, the square root of 3,600. 3,600. It's 60. Oh, I'm happy that Neo also got that. I'm glad that Neo also got that. I'm glad that Neo also got that. Any question? Lisedi? Okay, the other things I want us to discuss. I received some questions from Neo. Okay, f of x equals minus 2x squared plus x plus 6. Sketch the graph of f showing clearly all intersects the axis. Okay, this one you can sketch, but I'm sure Neo's question was on the values of k. Like, determine the values of k such that f of x is k has equal roots. Has equal roots. They've given us this answer, but what do you think the answer is? How do you find the equal roots? How do you find the equal roots? Okay, this is what I want to teach. So we always call f of x y, but also call k y. Which is y equals k. Yes, you create a horizontal line, but determine the value of k such that, because this is like a point of intersection, two functions are equal to each other. The parabola and a straight line, you draw some straight lines. And then when you have drawn some straight lines, you look for the straight line that is going to have these properties such that the values of k such that this equation has equal roots. You see, if the roots are equal to each other, equal roots. Okay, so equal roots, then what exactly are the values of k such that we have equal roots? Right. Is when the line is here. Equal roots means that there's one point of intersection. Here there are two roots. There are 2 points of intersection. So the roots they're talking about are what? Are points of intersection. Are points of intersection. So here there are also 2 points of intersection. Here there are also 2 points of intersection. Here there are also 2 points of intersection. Here there is 1 point of intersection. There's 1 point of intersection. Here there are two. But how many do they want? Has exactly equal roots, 1 point of intersection. So which means that k must be the y value here. What is the y value there? It's 49 divided by 8. Where's the question? Where's the question? Okay, I received these questions from Neo, so I'm just treating them. Okay, let's look at the next one. Right, determine the values of k for which this one has 2 positive unequal roots. So there are 2 graphs. This is the graph of G and this is the graph of F. Minus x squared plus x plus 2. Half x squared minus x are drawn below. F and G intersected C and D. A is the y-intercept of F. P and Q are any points on F and G, respectively. PQ is parallel to the y-axis. Okay, we have that kind of information. Determine the values of k for which f of x equals k has 2 positive unequal roots. Two positive unequal roots. Two positive unequal roots. Right, 2 positive unequal roots. Lisedi, what's the answer? Lisedi, what's the answer? Lisedi, how far? We're going to do the corrections now, guys. Okay, so just take it easy. We're going to do the corrections. Lisedi, what do you think the answer is? Lisedi, what do you think the answer is? I'm going to go on up to like 20 past 8. Then we shall stop. Okay, because the other questions I'm going to do on sequence and series and other sections as well. Lisedi, what are the values of K here? Okay, now what things that 2 is less than K less than 1/2. Lisedi, what do you think? Okay, we shall do the corrections, but I want to know what Lesedi thinks. You'll forgive me, Lesedi. Because be like, why asking me? You'll be like, why asking me? You'll be like, why asking me? Be like, why asking me? Lesedi, what are the values of K? Okay. I'm still waiting for Lesedi. Lesedi is still thinking about it. Or is still working it out. Determine the values of K for which f of x equals K has 2 positive unequal roots. 2 positive unequal roots. Lesedi, what's your answer? Okay, now we're going to consider this graph here. So we have that we have f of x equals minus x squared plus x plus 2. The y-intercept when x is 0 is exactly at 2 for f, which is this one. And then now we just need to find also, okay, before we do so many things, because we need to determine the values of K for which this equation. So there is a graph which is y equals f of x, and there is y equals K. So y equals f of x has already been drawn. Y equals K is so many lines, but now to not to avoid drawing so many lines, we want to such that these are 2 positive unequal roots. 2 positive unequal roots. So here there's going to be a negative root. Negative, because x is negative. Positive. Negative, positive, yeah? Negative, positive. And then it is only the top here because you have 2 positive unequal. So you're going to have x is positive here, but also this is positive exactly at the 0, just exactly above, right, just exactly above. So just exactly above, you have positive, positive. Okay, positive, positive. Right, so we continue with our check here. We continue with our check. So which means that we just need to know how high should we go here. So we need to find the turning point here. For the turning point of a parabola, what is the turning point of a parabola? To find the turning point of a parabola, you use x equals minus b over 2a. X is minus 1 over 2 minus 1, which is 1/2. Which is minus 1/2 squared, 1/2 2, minus 1/4, 1/2 plus 2. So from 1/2, you remove 1/4, you have 1/4, which is 2 1/4. And so 2 1/4 is 2 times 4, which is 8 plus 1, which is 9 out of 4. Okay, so in the end, you would have x is 1/2, and then y is 9/4. 9/4. Okay, yeah, just take note of that. So the question is, what is the answer? So the K can be the line that you mean to draw, can go up to the, because if it is going to touch at the turning point, then you have equal roots, but you must go below it. So you must have 9 over 4, but you go below. But you must go above the y-intercept. You must go above 2. Another way to find the y value of the turning point is also to use calculus, but you can also use y equals 4ac minus b squared over 4a. Y equals 4a for the parabola is minus 1. C it's 2. B is 1 squared. A is minus 1. Which is minus 8 minus 1, which is minus 9 over minus 4, which means y is 9 out of 4. Same thing, but you can also use calculus to do this. Yeah, what's the question here? Because now you're going to have a point of intersection here is going to have x is positive. And also this one is positive. Positive, positive. So what is the answer? So in other words, this is going to be the answer. This is going to be the answer. All right, this is going to be the answer. Right. Yeah. Yes. The answer is this one. Because y it's 2, so you go above 2 because, yeah, you see, it's very untidy, this graph here. But you must look at the fact that this graph, you must draw a line that is going to cut positive, positive. Positive, positive.
Ngicela ungisendele mate ngoba asikhona ukwenza next mate. Ngiyacela. Ngoba mangabe
Right. 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 So you continue. We continue. Right, so now let me check what Neo is saying there. Yeah, so the answer must be why you can't go, because at the turning point, then you have equal roots. At the turning point, you have equal roots. So if at the turning point you have equal roots, we go slightly below the turning point. Okay, we have equal roots if the line a line touches like this as a tangent, but you need a horizontal line that's going to touch like this. Positive, positive. But now, then you must go up above 2, the y-intercept, because when x is 0, then y is 2. So you must go above 2, so k must be bigger than 2, but you must go below the turning point, the y value there for the turning point. Okay, where's the question about this question? Lisedi, do you understand Lisedi? Do you understand Lisedi? Do you understand Lisedi? Next question. Determine the coordinates of D. We don't, okay, with this one, I'm sure it can be done. It can be done. Okay, let me readjust here. Okay, I want to readjust this one. Okay, you see, this one here is f of x, which is x squared minus 2x minus 3. G of x is x minus 3. Determine the values of k for which f of x equals k will have 2 unequal positive real roots. 2 unequal positive real roots. Where's the question? Yeah, solve this one. Let me know when you're done. Two unequal positive real roots. Okay, this is the graph of f, and this one is g. Okay, who is done with this one? Who is done with this one? Who is done with this one? Isedi, how far? Neo, how far? Okay, so you must draw the lines. Here, negative. Here, positive. Negative, positive. Positive, positive. Here, positive. Okay, Neo thinks minus 3. Okay, that's fine. I know you're rushing. Your inequalities must face the correct directions. But this is what I read on the thing, on the charts. Possibly you're right, but yeah, we must find the y-intercept minus 3. And then now you go to the bottom. You got k smaller than minus 1 and k bigger than 3. K smaller than minus 1, k bigger than 3. That's what I'm reading there. So anyway, let's see which one is correct. So you must just find the y value of the turning point. So in situations like this, the y value of the turning point is 4ac minus b squared over 4a, which is 4. A is 1. C is minus 3. B is minus 2. A is 1. Minus 12 minus 4. Which is minus 4. So which means that this is going to be whatever x is, but y is going to be minus 4 for the turning point. This is the formula for the turning point. Okay, R now is written in order. Minus 4 less than k less than 3. Okay, I'm just reading from the charts. I'm just reading from the charts. So minus 4 less than k less than minus 3. So that in the end, then what we're having here is determine the values of k, for which we have 2 unequal roots. And as we're saying, at this pointer, you'd have to then say the line that is going to be here is going to have positive. And you have 2 unequal positive roots, which means between minus 4 and 3. Between minus 4 and minus 3. This is the answer. So yeah, no is right there. Any question? Who is lost? Who is confused with this question? Where's a question? Anything to add, remove? Anything? Clarity. Any clarity seeking questions? Any clarity seeking questions? No clarity seeking questions. In the absence of clarity seeking questions, I'm going to ask you some things. I know I can go through so many questions like this. I've included your questions now. I'm gonna include them. Let me see. Okay, I'm gonna take this one. This question has been trending too much. It has been trending a lot. So it can only be fair to give it some attention. It can only be fair to give it some attention. Right, it can only be fair to give it some attention. Okay, I'm gonna go until like 8:30. At least the most we can do is 8:30, and then because you need to sleep. We can't be here for the whole night because you need to sleep. You need to do other things. You can't just be sitting here all the time, you see. You can't be sitting here all the time. Okay, this one is a question that has been making the most news. I've seen it a lot on social media. I've seen it on our WhatsApp group, but also other WhatsApp groups. So I want to see if you guys can do it. A quadratic number pattern. A quadratic number pattern has a second difference of 6. The third and fifth terms are equal, and the sum of the second, third, and fourth terms is 42. Show that the general term of the sequence is this one. For some odd reason, this question has just been everywhere, like on social media. So I felt that it would be appropriate to give you guys a chance. Yeah, let me see. Okay, good. I've seen the attempts there. So I want you to tell me that, show that the general term is that. Can you show that quickly, please? 3 marks. Please, quickly. Do number 3.1.1. Do 3.1.1. Quickly do it. Let me know when you're done. Please don't unmute. Please don't unmute. Please don't unmute Kathy. I'm talking to Kathy. Please don't unmute Kathy. So, Neo and Lisedi, quickly run through this. Tell me the answer to this 3.1.1. You need to show that Tn is, or T sub n is 3n squared plus 24n plus 57. Right, so, okay, yeah, can I get the, please, Neo and Lisedi, how far? Yes? Okay, so how far, Neo? I've seen Lesedi's attempt and, yeah, I've seen also Kathy. But yeah, how far, Neo? What have you got? Have you got A, B, or C? Or all of them? What have you got? Okay. B. Okay. I've seen B for Kathy, but A quadratic number pattern has a second difference. The fact that there's a second difference of 6 means that 2a is 6, and divide by 2, it means 6 out of 2. It means this is equal to 3. Yeah. C is 57. So what is B? Now and Lisedi, what is B? Now and Lisedi, what is B? The third and fifth terms are equal. T3 is T5. So, but if our T sub n is an squared plus bn plus c, but now you are dealing with this, which is going to be a 3 squared b times 3 plus c. Yeah, just watch that one. So a 3 squared b 3 plus c. Okay, then we have a5 squared b5 plus c. Okay, this gives us 9a 3b plus c 25a 5b plus c. Then you have 25 minus 9, which is 16a, 5b, which is 2b equals 0. This means b is minus 8a. We have an equation. Right, because the third and fifth terms are equal. So this means this. But the sum of the second, third, and fourth terms is 42, which means that second, third, fourth terms is 42. Which is 4a twice b plus c, 9a 3b plus c, 16a 4b plus c is 42. We add all this because the sum of the second, third, and fourth terms is 42, which means 4a plus 9a is what? Is exactly 13a plus the 26 plus the 16. Right, which is 29. A. The B's are 2b plus 3b, 5b, 9b. Plus 2c is 42. Okay. So that in the end, so this is exactly what we have. Show that the general term is exactly that one there. Okay, yeah, so you can be able to get A is 3, B is minus 8a, and A is 3. Right. And so what we're then getting is basically that. So B is minus 24. B is minus 24. And if you solve here, you'll find that C is actually exactly 57. And therefore, you then say Tn is an squared plus bn plus c. Your a is 3, giving us 3n squared. The b is what? Is minus 24. The c is what? 57. So that is what we have here. Okay, yeah, this is n. This is exactly n. So where's the question? Where's the question? Is 777 a term in this sequence? Justify your answer. Let's check this one. So you have to find T777, which is 3777. You square it. 777. Right. 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 Continue. Okay, yeah. So yeah, what do you think? Okay. Yeah, so what do you think? Because now if this 777 is a term in the sequence, you'd have to equate and make it that. So which means you have 3n squared minus 24n. Then use a calculator. Yeah. Okay, good. We're gonna see. Okay, so we're saying 57 minus 777 minus 720. Okay, we're doing 3.1.2, so you can get the factors of this. Right. We continue. Okay, yeah. Um, okay, yeah, I'm trying to factorize this one. 3n squared. Try to factorize this one, 3n squared. Right, so you can factorize this as 3x, rather 3n, plus 36. X minus 20 equals 0. 36, which means yeah, it's n. Okay, I'm going to be referring to the charts. So n is equal to 20. Yeah, you can use the quadratic, yeah? So n equals 20, so yes. So this we've made a general term equal to this. Therefore, this is a term in the sequence. It's a term in the sequence. Where's the question about this? Okay, I just wanted to show something. I wanted to do something. 3.2, who can do 3.2? What is the answer to 3.2? Okay, it's too easy. We'll continue. Okay, I want us to do 3.3 here. You have this particular quadratic number pattern. Show that the sum of the first differences of this quadratic number pattern is this one. Do 3.3 quickly. Which one is that one, Neo? The evaluate one? Oh, okay. Neo suggests this one. Let's try the evaluate one. Please try 3.2. When you're done, let us know. When you're done, let us know. We continue. Just do 3.2. Let me know when you're done. Okay, who is done with 3.2? To evaluate. What answer did you get, guys? Good. How do I attempt this question? Who is done with the 3.2? How do I attempt this question? Right, how far? Do 3.2. Let me know when you're done. 3.2. Let me know when you're done. 3.2. Let me know when you're done. Please. Right. How far, Lisedi? Right. What is the answer, guys, to 3.2? What is the answer? How far? Yes. Neo is saying obviously there's a different things. Can I? Yeah, Lisedi, what is the answer to this question, please, Lisedi? Lisedi, please share your thoughts. Let us know what you think about this question. What is the problem? This question looks very easy. Kathy, how far? Kathy, how far? Right, so, right. We continue. Right, so now to continue, right. Right, so now I'm giving you 2 more minutes to try this question. We're giving you exactly 2 more minutes to try this question. Right, 2 more minutes to try this particular question. Right, 2 more minutes to try this question. Right. So how far? How far, guys? Right, how far? Right, how far? Right, how far? Yeah? Okay, because what you need to look at is you need to look at this with that. The difference is 3. This with that. The difference is 3. There's supposed to be 10 plus 11. And the difference is also 3. So you have 2 and 5. The difference is 3. 5 and 3. The difference is 3. 8 and 11 also the difference is what? The difference is 3. But if you look at these very carefully, you're able to see that it is 1, 2. What is missing? 3. 3 is missing here. 4, 5. 6 is missing. 7. 8, 9. 9 is missing. So you can look at these as you can get 1 plus 2 plus 3 plus 4 up to 299. Yeah, definitely, but the 10 is supposed to be there. So we're gonna do up to 299. So you can add all. Okay, if you also can assume 10 is missing, but 10 should be there. Yes, so you can subtract 3. Right, so you add all these, which is arithmetic, which is n over 2, 2a plus n minus 1 times the common difference. But you can also use last term, yeah? N over 2a plus the last term, or Tn. So if you want 2, 3, then you're going to have 299 terms, which is 299 out of 2. The first term is 1, the last term is 299. And then you're going to find that S 299, then you're going to use a calculator for this. So now, so this is going to be exactly that. So it's going to be 44850. I'll check the charts. Yes, please. So now, obviously, this would be when you add all of them, but you can see that the multiples of 3 are missing. Like, you need to also get another 3 plus 6 plus 9, and so on. So you need those multiples of 3 as well. Right, so you need those multiples of 3 because those multiples of 3 are the ones that will obviously be very, very necessary. Right, so that is what then you need to do. Right, that is exactly what you need to do. So now you need to yeah, 9, because 9, 3, 6 are all missing, but also 10 was potentially missing. I would indicate that this question was typed very erroneously. Right, was typed erroneously and therefore not a very good question to do. But now, as said, right, then you'll have to subtract the multiples of 3. But then you need to work out the biggest one, the biggest multiple of 3 that is going to be before 299. Right, the biggest multiple of 3 that is before 299. To say if you add the multiples of 3, what is the last one? You'll see that it will be 297.
Yeah.
You agree 297?
Are you good though?
Okay. So that, yeah, okay, that is something that you need to take note of. So you deal with the S299, so you add all the terms. Then now you actually obviously are in a position to deal with the multiples of 3. Yes, please.
Sir, can you please try to re-explain how we got 287? Because I'm kind of confused.
Right. So
I'm kind of confused.
yes, the 297 would be when you add all these multiples of 3 to then say obviously 297 is actually the one that is before the 299. Right.
And so on, and so
Yes.
it is divisible by 3.
Now that is what you need to check the largest multiple divisible by 3. That's the thing. So it is the largest one divisible by 3. Because
Okay,
if you
thank you.
check, if you check 299, you divide it by 3. You want to see the ones that are divisible by 3. So you have 299. Okay, you divide this by 3. You say 3 goes how many times into 2? It doesn't. 2 goes how many times into 29? Right, and you'd realize that it goes 9 times because it divides 27. You divide, 27. Then you divide by 3. Right, you have a 9 here. So you'd have 27. And then 27, you subtract 27, 29 minus 27, we have what? You have exactly a 2 and a 9. 2 goes how many times into 29? Right, so you'd be able to see exactly that if you divide these, you divide 29 by 3, I said it goes 9 times because it goes in 27. Then you multiply, you get 27. Then you have 2 and then 9. And then you have 29. Yes. So now if you have, for instance, a 9 there, and you multiply these here, you have a 27, then you subtract, you have 2. Right. So that is what you will then actually be in a position to get. Right. So now you then say, if you use a calculator, okay, I want to use a calculator to check the numbers. So you have 299, you divide by 3. Right, so you get exactly 99.6. Yeah, most definitely. So you'll see, therefore, that if you actually are able to get the last term of these, you'll be able to see that it is 297, which is exactly 299 minus 2. But you take a calculator, 297 divided by 3. Right, so you can see that it is exactly 297 because you subtracted this remainder. So you take 299 minus 2, you get 297. But you have seen that, yeah. Okay, what are you evaluating here? So you take 297, divide by 3, you get 99. Okay. So now these are the multiples of 3. Okay, because this one is divisible by 3, giving us 99. So now you need to find the sum of these terms. But how many terms are there? So you're going to use Tn equals a plus n minus 1 times the common difference to find the number of the terms. Oh, yeah. And then this is the case. The last term is 297. The first term is 3. The difference is 3. Okay, if you divide by 3, because the difference is 3, the first term is 3. So dividing by 3 is going to be 1 equals 99. You can do something like this so that n is 99. So they're going to be like 99 terms here. They're going to be 99 terms there. All right. So now you're going to do Sn equals n over 2 a plus that one. So you have 99. The first term is 3, then the last term is what? Is 99. So you have 99 divided by 2 because there are 99 terms. The first term is 3 plus 99. Okay, which is 5049. 5049. So in principle, then what you're going to do is you're going to take, to get the sum of these, you need to take the biggest sum, S299 minus S99. So S299 is the 44850. Subtract the S99, which is 5049. Subtract, I suspect that just means the 10 there. So that when you use a calculator, you're going to have 44850. 5049. Which is 39801. 39801. Okay, 39801. Okay. And the 39801 is sort of the summation that is required there. Okay, I was just doing this question in evaluate because I took it from the WhatsApp group. Many students were just trying it. Many students were just trying it. Right. Many students are just trying it. Okay, on average, that has to be the answer to the question. Who is lost here? Who is confused? Who is lost here and who is confused? Right. So let me check. This would be correct. Okay, yeah, I meant here the last term. The last term of the multiples of 3 is 297. So using a calculator, okay, you are having 99. Yeah, I'm going to check the charts, please. So the last term of the multiples of 3, as said, that one is supposed to be 3 plus. As we said, it is 297. Which is 14850. 14850. 14850. 14850. So now here I want to say, then you're going to say 44850 minus 14850. minus 14850. 14850. Let's use a calculator. Yeah, I'm going to check the charts. So it's going to be 44850 minus 14850. 44850 minus 14850. It appears that we're getting 30,000 exactly. It appears that we're getting 30,000. Right. Where's the question? Let me check the charts. Yeah, 30,000. 30,000. I've seen that from Lesedi as well. Seen that from Lesedi. So where's the question? Where's the question? This is an average what expected. I suspect this guy just left a 10 here. We can just accidentally left the 10 because it's supposed to be between 8 and 11, you know, in the typing process. But yeah, this would be the answer to the question. Who is lost and who is... Yeah, any question, anything else? What should we do, guys? What should we do? The exam is tomorrow. Neo, what do you think? Your questions, we did some of your questions, but yeah, I don't know which ones are outstanding. Okay, good. Let's please summarize the approach. Okay, to approach this question, you're supposed to see that it's only missing multiples of 3. That is the easiest way, but there are too many ways to do it, of course. But it's 1, 2, then 4, then 3 is missing. 4, 5, 6 is missing. 3 is missing, 6 is missing. 7, 8, 9 is missing. Then there is 11. The 10 was missed by mistake. And then you can see that they're only missing multiples of 3. But the rest of the integers are there, up to 299. Then you find the summation of this. You find the summation of these. So now you find you add all of them. Now you include also the multiples of 3. If you add all the integers up to 299 with the multiples of 3, everything, you'll see that the last term is 299, the first term is 1, and then now the terms are, if you stop at 2, there are 2 terms. If you stop at 3, there are 3 terms. If you stop at 4, there are 2 terms. You stopped at 299, then the number of the terms, n, is 299. N is 299. But the first term is 1, the last term is 299. Then you find the sum, which is 44850. Then the multiples of 3 that are missing. The multiples of 3 that are missing, 369. What is the biggest one? So I decided to take the last one, 299, and you divided it by what? By 3. And then you got remainder 2, meaning that you can just subtract what? You can say 299 minus 2 to get 297, meaning 297 is the last term of the multiples of 3. And then which means Sn is n over 2a plus L. Then now it means that when we use the Tn equals a plus n minus 1d, the last term is 297. Then we can get that n is what? N is N is what? N is 99. Because if the last term, okay, you see, if the last term is what? Is 297, then you can see that N is what? 99. Okay, if N is 99, then you put A is 99, 99 out of 2, A is 3, 297, and then you see that the sum is what? Is 14850. 14850. The sum of, there are 99 multiples of 3 up to 297. Then now you'll say, okay, the sum of all the integers from 1 up to 299 is 44850, but the sum of the 99 terms is what? 14850. You subtract and then you get 30,000. Where's the question? Who is lost? I think we've done enough for today. Right, where did you get 99? That's a good question. 99 is obtained here. 99 is obtained here. To get 99, which is the value of n, we use Tn equals, because this is arithmetic, Tn equals a plus n minus 1 d equals 297. The first term of the multiples of 3, okay, good. And then if the last term of the multiples of 3 is 297, then we ask ourselves, what is n? What is the term number for this? So we actually use the 297, then we get n equals 99. After we got n equals 99, it means these 369 are 99 terms. And therefore, we can use this because this is the last term already. And the 3 is the first term. Then we can get the 14850. And then we then say the sum of all the numbers, 1, 2, 3, up to 299, minus the sum of the 99 terms, which is 14850. You subtract them. And then if you subtract them, you get what? 30,000. You get what? Exactly 30,000. Any question? I think we've done enough for today. I think we can call it a good night and say all the best. Where's the question? What else? Because I would like to continue, but yeah, at some point you need to stop. We can't go on until you run to the exam room. You know, because you must have time to sleep. You must rest also. You can't just sit on the screens until you run to the exam room. You're gonna be sleeping in the exam, and it's not right, you see. So you must practice a little bit and sleep. Let's practice a little bit and sleep. I must thank you guys for joining us. It was awesome having this discussion. We shall meet again tomorrow. What is the time? What time are we meeting tomorrow? Who can suggest the time for tomorrow? 4 o'clock or 6 o'clock? 4 o'clock or 6 o'clock p.m. Because you're writing paper one, you're going to be tired. You're going to get home and sleep. But I think we must have a lesson tomorrow. What time is best? Is it 4 o'clock or 6 o'clock? I'm thinking about it. But I'll let you know. But I'm suggesting 6 o'clock. Tomorrow I'm suggesting 6 o'clock because I think you would be rested and then we can start at 6 o'clock and discuss some things. That is my suggestion. Okay, let's keep in touch, guys. Then I will actually obviously keep you posted. But thank you guys for joining us. Until tomorrow, take care and goodbye, good night, and God bless. God bless. Goodbye, Neo. Goodbye, Neo.